Hi again guys, and welcome to lesson 7 of Mastering Hard Surface. Like last lesson, this is also another free lesson because I wasn't fully happy with the number of objects that were completed in the last lesson, and I also wanted to give you guys an opportunity to request some of your own ideas, and I've tried to include those in this lesson. So there's a few, I wouldn't exactly say advanced or complex objects, but they have the appearance of being complex, and I'm going to run you through how to create these just like last lesson, one by one, and I'm going to highlight some of the different methods and tools you can use to achieve these effects. So they're all relatively quick to do, but there is quite a good range here. And then lastly, I'll just show you how to, somebody asked me to finish off what it would be like to inset some text. Now usually I probably wouldn't do it this way, but for the sake of just knowing how to do it, I think it's extremely useful to know how to do type and work with type. So I'm just going to run you through kind of some of the topological theory behind when you're working with text. Alright, we'll just get started. You can see on the left here I've got a couple of knurled details, and we're going to construct that by starting with a single plane, creating the shape, and then we're going to bend it around the object, just like I've done quite a few times in the past. Alright, let's get started. Now, just like everything else I've always tried to teach, the easiest way to understand something and to achieve something complex is to break it down into its most simple part. And when you've got something like knurled details like this, you have to understand it's the exact same piece of geometry, just simply tiled a few times. So it doesn't, even though the end result appears a little bit complex, it's actually quite simple to set up. So to get started, we're just going to go from the front, and I'm just going to create a simple plane. I'm not going to bother aligning it to the center or anything. I'm just going to try and get through these objects as quickly and precisely as possible. So firstly, you want to make sure that it's square, obviously, and then I'm just going to convert that to an editable poly. The next thing I want to do is rotate it 45 degrees so that it's aligned correctly. You can see I've got angle snaps on, and there's an angle by default set to 5 degrees. You can change that wherever you want, to whatever number you want, just by going over the angle snap toggle and right clicking it. So later in the course there is going to be some things that do require some pretty specific angles to rotate objects on, and it's this option here in the degrees that we're going to change. But for now it's perfectly fine. So I'm going to rotate it 45 degrees, and the next thing I want to do is after doing that is I want to go in and reset the X form on the object, because when you rotate that like that, you're rotating the pivot of the object as well, and when you go to move it locally, you'll see now that the pivot is on the wrong angle. You can get around this by undoing that and going to the element and rotating the element 45 degrees, and now you can see that the angle is still correct on the pivot. But when you're working quickly, rather than doing that, I usually just find myself resetting the X form on objects enough to not worry about doing it on an element level. Okay, with this single polygon now created, I'm just going to select the inside, and first, let me just assign a material to this. And I'm just going to bevel it out. You'll notice I've left everything on those settings pretty straightforward, because now I'm going to go to the scale, and I'm just going to bring that in. I'm going to right click and convert to vertice, like we've done in the past, and then I'm just going to weld this. It's at this point where you can define how far out you want your knurled detail to go, but I'm just going to kind of keep it not exactly 45 degrees out, but enough where it's noticeable. The next step is going to involve changing where the pivot on the object is, so that when we clone this object, we're able to snap it to the borders. So what I'm going to do is I'm going to go to the hierarchy tab, I'm going to select effect pivot with snap on, and this is where it's a good idea to, you'll see here in the snaps options box, once right clicking that, you can turn on and off vertex snapping. So I've got that on. So now I'm affecting the pivot, and I'm going to move the pivot. Sorry, let me just turn on the snaps. And when I do that, it's going to naturally move. Sorry, just before I was showing you on the grid and snap settings, but it should be in here. So with our pivot now aligned to this corner piece, the next thing I want to do is duplicate the object down. And then rather than rotating everything again, what I can do is just rotate that into place. And depending on how high I want the knurled details to go, I can just keep doing that. So with this object here, I can just go down again. And down again like so. Now we've got a tileable piece of geometry. So I'm just going to go down a couple more times. And now what I want to do is to even off this top area, I need to delete these top two polygons. So I'm going to go into polygon mode and select these top two faces and delete them. Now I'm going to do the same again for the bottom. At this point, we've built the basic structure that we're going to bend around, but we first need to duplicate the object to the left. So I'm just going to attach all these objects using the attach box here. And now when I duplicate it, and I've still got that snap enabled, you'll see that I can make as many as I want. I'm going to stick to using copy, and I'm going to make the number of copies 35. Because we've already got one here, that's going to equal 36 copies in total. And now you can see we've built a pretty basic structure for which we're going to bend around. So I can turn snap off at this point. And now in the attach options box, what I'm going to do is I'm going to go to the top here and just drag over all of these. You can use Control A, so you can see if I've got just one selected. Using Control A will select all of them. So with all of these now attached together, we just need to bend them. So I'm going to use a bend modifier. I'm going to set the axis to X. I'm going to, oops, sorry. Sometimes you just need to experiment with that. I think I said in a previous lesson it's always pretty unlucky with whether or not it works. So in this case, I'm going to go to -90 on the angle. And then using Alt, which when you drag over a slider box and you don't have anything selected, you'll notice that it goes up at a higher value sometimes than you need for accuracy's sake. So in this particular case, 365 is the exact angle that it needs to snap. And you can see we're moving up in 1 increments. But if, oh sorry, in 0.5 increments. But if I hold Alt now, you can see now that that can go up by 0.05. So I'm just going to leave it at 365 and collapse this object. The next thing I need to do is I need to go in and select all the vertices, because you'll notice that we haven't snapped any of these. These are all single elements. They're not actually attached together. So I'm going to go in, attach those. You should be able to see the before and after number here drop. And now we're ending up with 504 vertices. And all those borders, the only borders we've got visible are up the top here. So at this stage, the next step is to go in and add the hardness to these so that when we smooth it, it's not turning into little blobs. So I'll just show you there. Right now, we don't have enough edge loops defining those pointy bits. So I'm going to go to edge mode, and I'm going to select everything but the border edges. And what I'm going to do after that, and this is totally up to you guys depending on how hard you want your object to appear, is I'm just going to chamfer off these edges. What you're left with is some pretty ugly geometry in the center here, but I've never really worried about this because when you're using a turbo smooth, like I said earlier in the course, and for those who haven't seen the actual full course, I do explain that when you're working with polygons, it doesn't matter if you've got triangles or n-gons or octagons or anything like that, as long as you're putting a turbo smooth on, because at the end of the day, when you do apply that turbo smooth, you're ending up with quads anyway. So you can see here, we've got a big open face, but as soon as I turn on turbo smooth, if you watch what happens, it fixes all that. And now we've got perfectly evenly distributed polygons. And it looks pretty good. So now the last thing to do really is to go into the top here and just extrude this out. And using our regularize tool, I'm just going to apply that. And it requires a little bit of trial and error about how big you scale this, because you'll notice now if I put Turbo Smooth on and scale in and out, it's totally up to you how you want this to terminate up the top. But if you wanted it to look like it was going straight from these pointy bits to a circular bit, what we're going to do is we're just going to add a couple more edge loops going up here so we can see what we're working with. And now smooth that. So you can see if I just go from below here, now I want to select these edge loops up the top, and using Turbo Smooth and Show End Result turned on, if I hit R now, when I cycle through, you can see I'm cycling through the different axes that I can use. So when I use all of them at once, you can see I can scale it in one direction, but that's not what I want to do. So I want to make sure that only the overall scale is available, and then I'm just going to shrink the object, and it can bug out a little bit. That's just a 3ds Max bug. I'm just going to make it the exact size I want and pull things down a little bit here. And now from above we end up with a nice clean knurled detail. At that point I can just go in over the top here, do whatever I want. And cap that off. And there you go. If I want, I can also add some symmetry to this underneath. And I just need to make sure that when I'm doing that, we're just up here. So now you'll notice I'm not fully capping off that bit of symmetry, because what I want to do is I want to weld these two together. So I'm going to collapse that. Sorry, bridge these two together. I'm going to collapse that, and now using the bridge tool, if I zoom in here, I'm just going to bridge these two. And we're left with a hard edge on the center there. And you can't tell. So that's the first piece I wanted to show you. And in theory, this should be able to work pretty much with everything. Right at the end, you might want to go into the hierarchy tab again and just center your pivot. But technically, if you have any kind of tileable pattern, you can bend it around, and even if you wanted to have like angled riveting on the inside of here, you can do anything. It applies universally. Okay, so next up, we've got another piece of geometry here that's got some knurling, but in a slightly different way. These are more kind of vertical knurls. So we'll get on to that now. So the next piece, the first step we're going to do is we're going to create a cylinder. Now, depending on how many knurled insets you want, you're going to have to go in and adjust the number of sides on the cylinder. In this particular instance, I'm using 80, and you can see how we don't have the exact same amount there, but we'll get there in a second. So the first thing I want to do is go in and define the shape of the overall object at this point in time. So I'm going to convert it to an editable poly, and then using bevel, I'm just going to drag out a bit of geometry, and you'll notice sometimes I do that just to give myself this bit of geometry to work with. And now I'm going to bring it up. I didn't mean to go in there, it's got to be completely vertical. Cool. Now I can delete that top face. Now the next thing I want to do is, sorry, I'll just bring this up just a little bit. and hide unselected. Just apply a bit of a correct shader to it. Alright, so the next step, we want to go in and we want to inset these knurls. So what I'm going to do is I'm going to select one edge around the object, I'm going to ring it and then loop it using Control W then Control E, and I'm going to use the extrude options box to create the initial insets. Depending on how wide you want your knurls, this is at the point where you probably should adjust that, but just keep in mind that when you go smaller here, that will also reflect what's happening. So don't try and get any pinches. And I'm just going to go a little bit deeper. Okay, so up the top now you can see we've got open surface, but down the bottom we've still got a cap. So what I'm going to do is I'm going to go into edit poly mode. In the polygon selection, I'm going to delete this bottom face, and you can see now we're left with this face here. What I'm going to do is I'm going to shift drag this down, and I'm going to do that once more. Now at this point you could probably go in and add the hardness to your knurls. So what I'm going to do is, it's a really cool feature. In the modify selection there's this similar box that you can tick, and what that does is it selects edges and vertices that I don't understand exactly how the algorithm works. Sometimes if your object's not completely symmetrical, it won't work as well, but I think it bases it on a couple of factors like the edge length and its angle in relation to the overall axis of where the object is. So what I'm going to do is I'm going to select this single edge here, and in modify selection I'm just going to hit similar, and now you can see it's selected that exact same edge, preventing us from, what this is good for is when you don't want to have to go in and model just one of these insets and then rotate it around 360 degrees. This just makes things a lot quicker because we can work on the entire object at once. So with that edge selected, I'm going to hit Control W, and that's going to ring the selection, and now I'm going to go in and add some hardness using Connect. I'm going to set 2 segments, and I'm just going to drag this out towards the edge. Now down the bottom here you'll notice we don't have any hardness defining this top part. So what I'm going to do is I'm going to select this edge, I'm going to right click and reduce those back to 1 and 0 and 0, and now using the same technique I've taught earlier in the class is I'm going to hit C to make edge constraint turned on, and I'm just going to drag this down and then drag it up a little bit, because sometimes this inset isn't perfectly vertically flat. You can do that if you want, but if you don't want to, I find when it is just a little bit higher up, it can produce a slightly different effect. Okay, so there's one little problem. We've got a nice edge flow and topology happening here, but we don't have the ability to select the entire loop if we want to go in later and define the hardness of this inside knurl. So what I'm going to do to make that easier is, and we could technically just leave this right now and just go to modify and select similar, and then you could shape for this if you wanted. But I'm also going to show you if I'm going to select this edge here, I'm going to hit similar for that, then I'm going to loop it, and I'm going to connect this. And that leaves us with a four-sided face here. So at this point, down the bottom here, you'll notice that it's not completely circular. Because we've got one large flat area and then a bunch of smaller polygons, this will not smooth exactly perfect. So what you can do to get around that is I can delete this and go to this base object and hit regularize. And you can see it's slightly ruined the overall shape. Sometimes it does that. I think what you can do to fix that is you can select the border and cap it. And then when you select that polygon and regularize, nope, it's still doing it. And that's because edge constraint was turned on, sorry. So now I'm just going to try one more time. You can see it kind of wigs out a little bit. Weird. That's 3ds Max for you. It's not working exactly like I thought it would be. So I'm going to try and go in and I'm going to select these 2 vertices and select similar for those, and then just connect them. Now we've got a full loop selected. Hopefully this works. It's still, usually it will evenly distribute those. Once again, when I'm working on this course, I'll rehearse things a few times, then when I go to actually do the recording, it just doesn't work as I expect it to. Okay, so in order to fix this, I'm just going to collapse the X-form of the object just in case. And I'm going to go to that border now, and just to make things a little bit easier to tell what's going on, I'm just going to drag out an edge loop here, and I'm going to select this ring and then use the regularize tool, and you can see if it does wig out like this for you, it shouldn't actually do this, but I do think it's important that if little bugs come up that do happen in Max, I show you how to fix them. What you can do is bring up the angle snaps toggle and change it from 5 to 1 degrees, and now when you rotate, it should eventually just click exactly where it needs to be. Now we can delete this outside edge, and at the base here we're back to having a perfect circular object. And if we decided to continue down, when we smooth this object now, it's going to be perfectly smooth and you're not going to get little bugs and things like that happening. So I'm going to put 2 smooths on that. Now you can see that we've got the bottom sorted. Just cap this off. But for the top, we need to do things a little bit differently. What I'm going to do is I'm going to select this border. Once again, I'm going to shift drag it up and then scale it in. Now you could technically just leave it like this depending on what you want to do, and then scale it in a little bit more, and then once more, and then use the regularize tool. And that will produce a specific type of knurling. So if I go up the top here and add some hardness to that, you can see it produces a pretty cool result. But you can also do things a little bit differently. If I just go back here, when I go to the border, if I drag this up, I can regularize this shape also. And now when I bring that in, and I'm going to go in and add that same level of hardness that I had here using the two edges in connect mode, and that will produce a slightly different result. So depending on what your goal is, you can do it either way. I'll just run through and do it once more. So you scale it in a little bit. You can see we've got enough geometry there, and then once more, sorry, and then it's then that you can do that regularize script. And all the topology, it might not be perfect, but it gets the job done. And from this point, you can go in and then, like I always like to do, just add a little bit more detail. So there you go, it's a nice perfectly clean knurled surface, and it's as low res as it can possibly be, keeping in mind that you may need to continue on that surface and you don't want it to appear edgy. And that's the best way I know how to do these types of details. So we'll just go on to the next object now. So this next object may appear quite simple, but there's a couple of little steps required in order to not get the pinching that you would usually see around the edge of where this extrusion happens. So let me just isolate this object, and we'll just get running through in how to create it. So the first thing you want to do is you want to start with a cylinder. So I'm just going to start with a cylinder here, and I've got 20 sides on it. Depending on what other details you have on this cylinder will determine how many sides you want. But I think in general you want to try and keep, the purpose of this is to show you how to create extrusion like this on a low res surface. So I'm just going to delete the sides of the polygon. I'm just going to delete back here also. Okay. Now the next thing I'm going to do is I'm going to create two loops along the side of the object. And now from here, what I can do is I can select these polygons and delete them. Now I want to go in and select these border edges and bring them up. And then I'm going to flatten them. Because we're just getting in the way here, I'm just going to remove this bit of geometry. And I'm going to create two more loops running down the inside just so we've got a little bit more even distribution of polygons. I'm going to do the same for this side. And depending on what you have towards the edge here, I wouldn't recommend adding more loops than you need, so I'm going to get rid of those. Holding control while hitting remove there. Now I'm going to go in and select these back edges and drag them up. And getting these two edges, you can see they're not welded. I'm just going to drag over these two and weld them up. And when I've done that, because I didn't drag these up at the exact same height, I just want to make sure that when I do that, I go in and reflatten that using the Y button. So from here, now we can figure out how to get this shape. So what I'm going to do is I'm going to select all these edges here and just select them exactly how I've done. And we're just going to chamfer. Depending on how hard you want this will also determine how big you go in the chamfer. But for our little test here, I'm just going to keep it this big. So up the back here, you'll notice that we've created a couple of triangles. So what I'm going to do just to quickly make this a little bit cleaner is just cut an edge along the outside just to clean that up. And now if we ever wanted to, and I'll show you in a second, if I just get rid of that inside loop. Now if I ever want to go in and add some edge loops along here, we've got a nice flowing bit of topology. So up the top here isn't that important, but I'll just cap this off. What I like to do is I like to go in and select these two edges and then just grab this whole thing and then inset it. I'm going to delete this polygon back here. And now I like to grab all these edges up here and flatten them and just pull them back. So now you can see I'm just selecting these back edges and I'm just going to drag those up. If you do get a little bit of an overlap here, feel free to just undo that. Because this surface at the top here is perfectly flat, you don't need to worry so much about the spacing between these vertices. Just as long as they're good, you shouldn't be able to tell by eye what's happening. So the next thing I can do is now I can add an edge loop up the top here. So I'm going to use the options box to do that and just level that to 1. And using the same method I was showing you earlier in the lesson, we're going to turn on edge constraint toggle and drag that up and then back down. And now we can see what this looks like smoothed. Now you can see it looks pretty good, but there's one little problem we're getting here, and that's whenever you have a curved cylinder, something extruding out of that, you end up with this bit of pinching here. So to fix that, it's just a simple solution, and this is why I wanted to show you this piece, because if you go in and select these vertices, using show and result, I'm just going to drag down. And what this does is it helps minimize that. Sorry, I just was dragging down with edge constraint turned on. And now you can see when I drag down there, The pinching is noticeable, but you're just minimizing that as much as possible. And usually when you go and render something like this, it's not fully noticeable. So once again, on the edge here, you've got a 5-sided point, but if I turn off isoline display, it's nice and quadrangular. Let me just apply a shader to that. If it's still causing you a little bit of grief, you can always go in and select all of these and just move them in a little bit. And this should also further reduce that effect happening. So unless you're seeing this from the absolute most extreme of angles, you should be able to get away with this, because there's quite often lots of small details that require this type of extrusion. But you don't want to go in and have a 50-sided cylinder, so you're minimizing that effect. So that's the topology required for something like this. You can see I haven't worried so much about the top here, but that wasn't the point of this piece. Okay, moving on. This next piece, once again, seems a little bit complex, but it's actually extremely simple to set up. As usual, we've got some weird 5-sided faces, but when you see what it looks like smooth, they all produce pretty nice flowing topology, which is great for later on if you wanted to go in and say, for example, let me just duplicate this, collapse it at this level. Then you could go in and you've got loops that you can select here and possibly connect and add hardness to if you wanted. Just want to re-smooth this. You get that effect happening, which looks pretty cool. So in order to do this, what I'm going to do is firstly, I'm just going to set up the piece that I'm going to actually inset this circular bit into. And now if you look really closely, you'll see that this doesn't smooth perfectly fine, but when you're looking at some of the character models and things like that I've done that aren't so industrial and you want more of a sci-fi soft design shape to it, this works really well. So what I'm going to do is you can base this on any kind of inset you want, but I'm just going to steal this one that we've already got here, because basically this is just creating a plane and dragging in a little bit of a inset there. And I'm just going to flatten this off and drag out again. So this is the starting shape for our object. You can see it's quite simple. It's just a flat plane with a couple of insets. And when we smooth that, that's the result it's giving off. So to get the circle in, I'm just going to take the turbo smooth off, and we need a couple of edge loops here. So the first one I'm going to connect. I'm just going to go into the options and make sure that the settings are reset. So we're going to connect one down the center, and we're going to connect another down the side. The next step is actually getting the perfectly circular edge loop cut into the object. So what I'm going to do is I'm going to go from front on, and I'm going to bring up the splines menu. I'm going to create a circle, and then with snaps on, and remember I've got that vertex mode on. Now you can see when I hover over that inside little loop, there's a little yellow circle that comes up. And I'm just going to drag it out, and you'll notice that even though I let go, it's kind of just bugging out a little bit because it's trying to snap to different points. When I let go, it's going to just be whatever size it's snapping out to. So I usually like to go in and just scale this vertice. Now you want the circle to be inset so that this corner point here, and sorry, I should make note, when you first create a circle in Max, I think the steps is set to 5, but you can see there's too many polygons here for us to work with. So I'm going to bring it all the way back down to number 2, and that's the level of interpolation we need. So once again, I'm just going to scale this until it's rough, so this corner point is roughly in line with that edge loop. We're going to have to go in and weld those a bit later though. So now the next step is to actually go into the Edit Poly and go into the Compound Objects menu, and this is where we can do a shape merge. And what a shape merge will do is it will project from the view you're in, the spline you're about to select onto the surface. It's going to project that topology. So I'm going to hit shape merge, pick shape, and then select the circle. It's an old technique I've always used for ages, but once again you'll see that Max is a little bit buggy when it comes to doing things like this, and it's probably going to introduce some vertices that we don't want. So you'll see when you're finished, it's going to be called shape merge. You just want it to go back to being an editable poly object, and there you go, like predicted. There's a lot of vertices here that shouldn't be there. So we just need to go in and clean those up. So using target weld, I'm going to go in and just one by one clean these up. And when you do have a 5-sided point like this, I usually just bring this edge loop down. And if you ever needed to clean up that polygon distribution, because you'll notice that now the difference in edge length between here and here is different, usually you can just go in and just, you know, with edge snap turned off, just drag that up until it's the same height. So just zooming in one by one, I'm just getting rid of those unwanted loops. And it was these corners here that I said that I wanted to go in, so I'm just going to select those, and I'm just going to weld all these. And just keep removing these unwanted vertices. I think it's pretty crazy now that we're in Max, well, I'm in Max 2014, but we're in Max 2015, and something as simple as that still hasn't been fixed, but that's a type of stuff you just have to deal with if you're just going to be working with Max, because I just don't think they're willing to fix things like this. Okay, so I've done a cleanup now. There's no unwanted vertices, at least that we can tell. I should note that whenever you're doing something like this, sometimes because it seems it adds those random vertices at a completely random points, you might zoom in at one point and realize that it's created this tiny little vertice right here, and then when you go later on to regularize this inset, the number of vertices is unaligned, and that's most likely why it's been caused. So when you do a shape merge, it usually has all the polygons selected. So I can select these, and I'm just going to delete them. The next step is I'm going to go into the border and shrink this and put a regularize on. So this is where I was saying just be careful, because if you don't have the correct number of vertices, and I'll just show you this. Let me just attach one here and get rid of this. Sorry. Now you can see that that vertex is there, and if I go into the border and regularize it, things aren't lining up. So just be careful there. Okay, with that done, I'm just going to pull this in, and I'm just going to flatten that. And I'm just going to drag in, shift drag in an edge loop. At this point, I want to put a turbo smooth on and see where we're at. So as is, it's a pretty good shape, but we're not quite there yet. Let me just go in and add a little bit more detail to this inside part. The next thing we want to do is we want to create edge loops along the edge here. So rather than going in and selecting this loop and chamfering it, which is a possibility if you want to do it that way, but usually what I like to do is I like to go in using edge constraint toggle and just shift drag this in, because I find it produces a slightly better result. And then just drag this out. Now we can grab these 4 points, and with edge constraint turned on, just scale them up. And there you go. That pretty much wraps up how to create that type of shape. But you'll notice down the bottom here, if you do have a little bit of a messy surface, what you can do is you can select these edge loops and just pull them back a little bit. I'm just going to scale those up. With edge constraint turned on, I'm just going to scale those up, and it should just clean that just a little bit more. But like I said, you're usually trying to get these details in, and when you render from quite a far bit away, you don't notice all these tiny little warps and things like that in the geometry. But this method should technically work on any number of insets. So you could, if you wanted, now that you've created this shape, go in, maybe select a couple of vertices here, and connect along here, and just chamfer this. Connect in here with two more. And just do things like that to create even more detail. And you can see it smooths, not perfectly fine, but you'd be surprised how much detail goes into my character models and things that do have tiny little problems like this, but when you render it from back here, you just can't tell. So I never really found the point in wasting time going in and making sure absolutely everything was perfectly clean when you can get away with things like this. Alright, the next step is to create some little rivets and, sorry, not some rivets, some little insets into a flat panel. And this is the type of stuff you might see on like shotgun handles or just bits of sci-fi corridor or anything like that. In order to save a little bit of time in the video, I've just skipped ahead to creating this plane that we're going to inset things onto here. But this, once again, in theory, can be any shape you want. And now I'm just going to show you how to go in and create this little inset surface. And you can see the topology works really nicely. It doesn't produce any pinching, and it's extremely low res. So the first thing I need to do is I need to go in and create a connection down the center. And then I'm going to create two more. And once again, this is where I like to go in and just do this. We can just leave these on the outside. Actually, I'll get rid of them. I'll get rid of them because we're going to tile this later. The next step is to go in and create these connections. Now what I want to do is I want to go in and weld these vertices towards the center here and get rid of the ones below. So now you can see we're left with two triangles. But what we're going to do next is we're going to go in and select this edge loop and we're going to chamfer it. And once again, depending on how hard you want this inset to be, this is where you'll define how wide this is. You'll notice that throughout my career on objects, I always go very soft with things. I don't like making things extremely sharp in 3D, because what that means is it means when you need to go and anti-alias those edges, they're too small and it's just making more work. So my style slowly shifted towards softer edges. Now we can grab all of these vertices here and weld them. And that's just going to leave us with a really nice clean bit of geometry. Now what I want to do is I want to select this vertice and weld it up the top here. And now I can get rid of these two edges and we're left with quads. So at this point, all I need to do is select these inside bits and drag them in. And then we can go up the top here and connect some more hard edges if we want. We can do the same for there. But if I put a turbo smooth on this now, you can see it works perfectly fine. There's no problems with it. And it's as low res as you can physically make something like this. So at this point, really the only thing to creating multiple little bits is to once again I'm just going to go to the pivot of the object and I'm going to snap it towards the edge here. So I just need to take off turbo smooth when I do that. I'm going to go into the effect pivot and snap that to the edge there. And now I can just duplicate this. So with snap off, there's one little thing that if you ever are duplicating lots of objects together and you're not sure which vertices need to be welded, what I usually like to do is I go to border mode and select the border and then convert that to vertice mode. So now it's only got the vertices selected where you don't have unwelded surfaces, and obviously the outer edge. But it just sometimes minimizes the risk of welding vertices together that you didn't want to be welded. So you just need to go down on the... Yep. And now when I smooth this, they should all line up nice and evenly together. And you can just scale this down. You can see it doesn't really work. You got the same type of effect happening. But it's probably a good idea to go in and add one more edge loop up the top here just to harden this top edge off. Because the way the polygons are distributed, it will create a slight little rippling effect if you don't do that. So always make sure that to have that edge loop here. Alright, so we're working our way through some of these objects now. There's only 2 more to go. Now the next bit of detail wasn't exactly requested to me, but I thought I'd include it because it's quite an annoying thing to create without pinching. And that's kind of a inset edges on cylinders like this. In order to create it, we're going to start with a 20-sided cylinder. And what I'm going to do is I'm just going to bring this up here and apply a shader. Then I'm just going to bevel in, and once again, once you know the angle you need this to be, you can't change this after because there's too much topology running through it. So you need to get the height and angle of this done correctly at the start. So just pay close attention to that when you are working on something like this to get it right now. Now I'm just going to delete that inside bit. Now I'm going to delete this bit also. And what we're left with is just a angled cylinder. And I'm going to connect twice in between that, and it's just going to be an even connection. Now I'm going to go in from above and delete everything but a quarter of it. And from here, I can just... Actually, before I go in and delete that, I can just go in here, and I'm just going to connect from one side to the other. Now I can get rid of all those polygons. So now we've got the cut we need. Now I'm just going to go in and get that circular shape happening by creating some symmetry. And we can start to work on fixing up this bit of geometry. So what I'm going to do is I'm going to weld these 2 parts. And then target weld this bit here. Now what I can do is on this bit, I can connect up to here and get rid of this point. And what we're left with is a nice even quad surface. So selecting this vertex now that's a little bit out of sync, I can go in with edge constraint toggle selected and just kind of drag that in just to give it a little bit of roundness. And I can pull these edge loops up because I want them to kind of run along that edge. Now what I'm going to do is I'm going to connect slightly off center to here and get rid of this edge loop. And you can start to see that we're kind of reworking the topology to work with us. From here, I'm going to go in and chamfer this. Just a little bit more. And just target weld this back up again. Now I can technically delete this object, or what I can do is I can connect 2 lots and then delete the inside here. So we've got 2 nice clean edge loops. With all that selected, from here I can technically drag down, and if I put a turbo smooth over the top of this now, and always make sure when you're working with symmetry that that goes over the top, you can see that things are smoothing quite nicely. However, there is one problem, and that's down the bottom here. Because we've disconnected those vertices, the smoothing is not happening exactly how we want. So what you need to do is you need to turn on show end result, and then just drag in to kind of counter that effect that's happening where it's becoming pinched. You can sometimes, if you want, just drag this out a little bit more to even things up. Ultimately, what we are doing here though is we are getting away from a perfect mathematical cylinder, and if you ever have car parts or something extremely chrome-like reflecting here, sometimes pinches can happen. So just be aware of that when you are working kind of low res like I do, that things like that can happen. From here now, because the topology is perfectly clean, we can chamfer this edge and it should work out nicely. I can just, whoops, I can go in and connect these two. When you're happy with it, and like I said, you may need to go in and just play with some of these shapes, even if it means not having a perfect circle anymore. But I just like to sometimes go in and just, just see what's happening, trying to keep that roundness. From here, when you're done, you can go to the top cylinder symmetry and collapse that. And now in border mode, feel free to go in and add whatever type of detail you want here. And there you go. It's a nice, quick and easy method to create a really cool shape and a really cool detail. There's a lot of opportunities to use something like that to add some complexity to maybe some like sci-fi riveting, where the rivet isn't just a simple cylinder, it's got some crazy detail to it. And when you have enough of these and when you render them, it can be enough to kind of wow people when you've gone in and put the effort into little bits of detail like this. Alright, now lastly, somebody requested for me to show them how to do type, and you can see here that there's a lot of problems in this mesh, but when you smooth it, they're not noticeable. And as usual, whenever you have a flat surface, I mean, if you're willing to put the effort in, feel free to go in if you see things like this and just clean them up. But if you aren't and you're lazy like I am, once again, when you look at the turbo smooth object here, everything's still quads, and this is a perfectly flat surface, so you can get away with it. So I always like to do the absolute bare minimum, A, to save my wrist from being in pain, and B, just because a lot of the times it's not necessary to go in and refine things to the point of perfection, especially in CGI, where there's a lot of the time the more obvious flaws in your renders are shaders and lighting as opposed to the modeling. You can actually get away with a lot more than you realize if you have nice realistic shaders. Alright, to create this object, I'm going to go in, and what I'm going to do is I'm going to use 3ds Max's text tool. I'm just going to click in the viewport and feel free to type in whatever you want. For this one, I'm just going to hit go, just make it a little bit simple, and I'm going to change the font. Once again, if you want to change fonts and you don't want to have to manually go in and select all these, a cool little tip is if you select in here, you can just use your scroll to find the font you like. And remember, when we are working with something like this, the majority of the time, the more square and simple the font is, the better result you're going to have, and the less work you're going to have. Obviously, a lot of the time, that's not up to you. That's up to clients giving you fonts. But especially if you're working on your own designs, try and find one that's really blocky and sci-fi. So for this, I'm just going to use Impact. which is a really blocky font. Actually, we'll make the word a little bit more complex, and I'll just keep it the same as what I was doing before. Okay. Now I'm going to scale this up. And the next thing I want to do is I want to put a quadrify modifier on. This was a modifier introduced, I think, around 3ds Max 2012, and it's awesome. It's probably been one of the most useful and most commonly used tools I use that Autodesk have added since the old days, like since 3ds Max 2009. Apart from little things like this, my workflows stayed pretty much identical. Alright, so I won't go into detail yet about the quadrify mesh in this particular tutorial because we're running out of time. But what I will do is make sure that you're aware that when you are using the quadrify modifier, you can go up and down in the quad size, and what that's going to do is it's just going to 3ds Max is going to do its best to determine where the edges are and then create an even distribution of polygons over that surface. So you can see if at 2% here I've got probably too much geometry to work with, because when we are creating this text we're going to have to manually go in and bridge all these points together, which can be quite annoying. So you want to go up to the absolute max you can where you're not getting little problems like this. So I like holding Alt and then just kind of going down until I've got what I think is a pretty good distribution of polygons, like so. And then I'm just going to collapse this into a editable poly. Now from here I'm going to go to the border and I'm going to hit extrude, and I'm going to reset these, and I'm just going to do a tiny little inset here, and this is going to serve as the edge loop that's determining the hardness on the inside of this inset. With that border still selected, what I can do now is drag outwards, and you're probably going to want to drag out once to create the hardness on this inside bevel, then again to determine the depth of the inset, once more to determine the hardness for the outside edge, and now we want to use extrude again, but this time I'm just going to use the height tool, the height options, just to create a little bit of a border around this bit of geometry. So from here it really basically is just grunt work. It's just going in and connecting everything up. So I'll quickly run through that with you and show you what I'm talking about. So what I'd like to do usually is I'll probably select, and the reason I wouldn't do it this way is because I'm just quite lazy. What I'd probably do to create text on, I think the person requesting it was asking to do the text on the inside of a wrench. Sometimes you get some mechanical information required on the tool to be inset in. And if you're not prepared to do it this way, which is the slow and boring way, what I would probably do is right at the end of modeling the whole tool, I'd go into ZBrush, subdivide it a few times, then use a Photoshop file to displace in that text. I'll just draw out the text and displace it in, and then use the optimization on the model, which is a little bit lazy. You're not going to end up with a nice clean object, but it gets the job done. I think it's been quite a while since I've done text like this. So then from here you just want to drag up some points to start working with. You can just start connecting these off. Always try and find the absolute bare minimum to do. So I'm just going to drag out some points here. Now I'm going to bridge these two. Can bridge this tool, can probably bridge this polygon and this polygon, and you just work your way through it. When you get to areas like this, I can just go in and cap them off, and then from there it becomes a little bit easier when you just go in, and like I've had from the beginning, I've got G connected to the connect options box. I can just start connecting in vertices, trying to keep them quads, but it doesn't matter if you don't have them quads. You can see here we don't have any. But basically I just try and find the furthest areas away, and then we'll just cap in, because it's much easier to select vertices than to go in and bridge things one by one. If you ever don't have enough topology, feel free to always go in and cut your own, just to make things a little bit more even. But you'll see that once I cut the absolute bare minimum in here, I don't need to cut all of these. And it's extremely lazy and it's extremely messy, but I'm just being completely honest when I say that if you've probably seen font on anything in my folio or any print jobs I've done, it's being done in this lazy way. Feel free to go in and add some more geometry. I always like to, I probably haven't pointed this out, but when I'm trying to select a bunch of specific edges, I like to use the plus and minus selections boxes a lot. So I'm basically focused on selecting this edge. So when I select that, because I know that's those I've already focused on the exact edges I want selected, I can just quickly go in and unselect, and if I ever need to just quickly go back in and select a couple I missed, it's just the quickest way I've found for selecting vertices like this. Now I'm just going to go in and weld these. And now you will notice that when I've done that outer extrusion, the edge loop spacing isn't perfect. However, when you do see a lot of mechanical details like this, they're not perfect themselves. It's not a complete science to getting these things put in. Sometimes it can be hand done and just hand using a router. They just go in and do it by hand, tracing a guide, or it can be done with lasers. But at the end of the day, I've never seen edges that come out perfect. But if I put a turbo smooth on this now, you can see that it's, even though all this geometry in here is really crap and all over the shop, it's still smoothing quite nicely. And you basically just keep going with this process, you know, just go in and bridge, and I try and do my best to create holes to cap. So now I can select this whole hole and cap it in. But when I've done that, you can see that it's there's not enough cuts in places to prevent overlapping pinching. So that's where I'll go in and just kind of, with edge constraint turned, with show and result turned on, I just connect points one by one to see what's the bare minimum of amount of work I can do to prevent those problems happening. And you can see as I begin to cut a little bit more loops in here, we're fixing up that geometry and we're not getting that overlapping pinching happening. And very quickly you can finish off your model this way without going in and wasting all the time on parts like this. But at the same time, because we've done things how we want, we can technically go in to these, because we do have nice clean edge loops, we can add a little bit of a bevel to these if we want. And you know, you get the point. You can kind of see how that works. And then basically from the outside edge here, all you need to do is just find a way to terminate these edges and get them flowing into the rest of your model. So I like to just try and isolate around the object. You can see up the top here where the text is, I've created some flat, perfectly flat border. And what that means is when I do have a larger object to fill out here, it's much easier to go in and get rid of geometry like this. Let me just show you. I'm just going to go around, because once again that's flat. If we have too much, we can just start going in and welding points together so that they will meet up with whatever geometry you have on the outside. So I'm not going to waste your time and go in and show you just how I'm just going to slowly finish that off, because you can see it is quite simple. You just keep going and you just keep capping off, bridging off the lower extremes and the upper extreme of the text, and then just fill it in, and then just go in and once again just connect those up. And when you've done the work, you'll end up with a nice clean bit of text. So there is one last thing I want to show you. You'll notice on the inside here we don't have hard geometry, so that's where you can go in if you want and just chamfer this to create that hardness. And once again, it's just down to how much work you're willing to put in to create clean edges, but I wouldn't advise manually going in and cutting edge loops like this. I do find it's more simple just to chamfer them. Okay guys, that wraps up this lesson, and you can see there was quite a lot covered. And once again, I'm really happy to offer another free lesson in the course. I should say at this point in the course, I do look at kind of the feedback I'm getting online, and I know a few of you have said that the course isn't covering anything advanced yet, and I'd completely agree with that. I'm just trying to, up until this point, get you familiar with reworking with a lot of tools, getting a lot of repetition happening. But I'm happy to say that lesson 8, which is going to be the next lesson, is finally we're going to go into a bit of design theory and how you can start to create some of your own designs, some of your own shapes, using everything that's been taught so far in these kind of fundamentals, and you'll see how that all comes together, and we'll spend the next third of the course going into some design theory. Then the final third part of the course will be tying everything together, so detailing your own designs and refining things. Thanks heaps guys, and I'll see you in the next lesson. I'm not sure exactly when it's going to be out yet, but my fight's on November 28th, so that's probably going to jumble things around a little bit, but I'll make sure to have another lesson out before then. Thanks heaps, see you later.